Overview Study on High Power PD Interface Controller by Linear Technology. Welcome to the training module on LTC4268, a high power PD interface with a switching regulator. Today's training outline consists of features and applications, functional block diagram, 2 to 4 pair high power PoE systems diagram, signature resistor, under voltage lockout and power good, load compensation, switch regulator, and application circuit. Linear Technology introduces the LTC4268-1, a power over Ethernet interface controller with a synchronous, current mode, switching regulator for delivering precise regulation and high efficiency to power-hungry power devices. The LTC4268-1 provides up to 35 watts for 2-pair systems and as much as 70 watts for 4-pair systems. It is an integrated power device controller and switching regulator intended for IEEE 802.3 and high power over Ethernet applications up to 35 watts. It incorporates Linear Technology's patented no opto feedback topology to provide full IEEE 802.3 isolation without the need for opto isolator circuitry. This slide offers information about applications and benefits of using the device. At the heart of the LTC4268-1 is a high-performance switching regulator optimized for isolated power over Ethernet applications. The LTC4268-1 is designed to be a complete solution for power devices applications with power requirements up to 35 watts. The synchronous flyback converter provides a low part count design with the advantage that additional outputs can be obtained by simply adding windings. Synchronous rectification offers the benefits of high output power, increased conversion efficiency, and improved cross-regulation in applications with multiple outputs. The LTC4268-1 interfaces with custom power sourcing equipment using a high-efficiency flyback topology for maximum power delivery without the need for opto-isolator feedback. A feedback amplifier senses the output voltage through the transformer winding during the flyback period and uses this voltage to tightly regulate the output. The transformer isolates the load from the input supply and provides feedback, improving output transient response and overall reliability. Once a power sourcing equipment detects and classifies the powered devices, it fully powers on the device. The LTC4268-1 provides a low inrush current limit, allowing load capacitance to ramp up to the line voltage in a controlled manner without interference from power sourcing equipment current limit. After the load capacitance is charged up, the LTC4268-1 switches to the high input current limit and provides a power good signal to its switching regulator, indicating that it can start its operation. During this time, the LTC4268-1 remains in its high current limit state, allowing for up to 35 watts delivered to the load. This slide illustrates 2-pair high power over Ethernet system. High power over Ethernet system can deliver power using 4 conductors or 8 conductors. Each method provides advantages, and the system vendor needs to decide which method best suits their application. As shown on the block diagram, 2-pair power is used in today's 802.3 AF systems. 1 pair of conductors is used to deliver the current, and a second pair is used for the return while 2 conductor pairs are not powered. This architecture offers the simplest implementation method, but suffers from higher cable loss than an equivalent 4-pair system. 4-pair high-power power over Ethernet systems deliver current to the power devices via 2 conductor pairs in parallel, allowing for an even higher level of power. This lowers the cable resistance, but raises the issue of current balance between each conductor pair. Differences in resistance of the transformer, cable, and connectors, along with the differences in diode, bridge forward voltage, and the power devices, can cause an imbalance in the currents flowing through each pair. Using 2 independent LTC4268-1s allow for interfacing. Power from 2 independent power over Ethernet and independent DC-to-DC converters resolve the current imbalance. This slide illustrates the detection of power devices through a 25,000 signature resistor. The power device's interface controller provides the same 25,000 signature detection resistance, defined in the standard power over Ethernet. An extended optional class can be read by a customized PSC that looks for such a class. Once a PSC detects and classifies the power devices, it fully powers on the device. Power over Ethernet applications require the power device's interface to turn on below 42 volts and turn off above 30 volts. The LTC4268-1 includes an internal port voltage lockout circuit to implement this basic chip on-off control. Additionally, the LTC4268-1 includes an enable or lockout function for the DC-to-DC converter that is controlled by the undervoltage lockout pin and is intended to be driven by the power ground to ensure proper startup. The undervoltage lockout pin also includes a bias current allowing implementation of hysteresis. When undervoltage lockout is below 1.24 volts, gate drivers are disabled and the converter sits idle. When the pin rises above the lockout threshold, a small current is sourced out of the undervoltage lockout pin, increasing the pin voltage and thus creating hysteresis. As the pin voltage drops below this threshold, the current is disabled, further dropping the undervoltage lockout pin voltage. If not used, the undervoltage lockout pin can be disabled by tying to VCC. The LTC4268-1 provides complementary powered good signals to simplify the DC-to-DC converter interface. Using the power good signal to delay converter operation until the load capacitor is fully charged is recommended, as this will help ensure trouble-free startup. The active high-powered ground pin is controlled by an open collector transistor referenced to VNEG, while the active low-power ground pin is controlled by a high-voltage open drain MOSFET referenced to V-port N. The power ground pin is designated to interface directly to the undervoltage lockout pin with the aid of a pull-up resistor to VCC. The LTC4268-1 uses the flyback pulse to obtain information about the isolated output voltage. An error source is caused by transformer secondary current flow through the synchronous MOSFET RDS on and real-life non-zero impedance of the transformer secondary and output capacitor. The secondary current only flows during the off portion of the duty cycle. This page shows the block diagram of the load compensation function. Switch current is converted to a voltage by the external sense resistor, average and low pass filtered by the internal 50K resistor, RCMPF, and the external capacitor on CCMP. This voltage is impressed across the external RCMP resistor by op-amp A1 and transistor Q3. producing a current at the collector of Q3 that is subtracted from the FB node. This effectively increases the voltage required at the top of the R1 over R2 feedback driver to achieve equilibrium. The LTC4268-1 includes a current mode converter designed specifically for use in an isolated flyback topology employing synchronous rectification. The LTC4268-1 operation is similar to the traditional current mode switchers. The major difference is that the output voltage feedback is derived via sensing the output voltage through the transformer. This precludes the need of an opto-isolator and isolated designs, greatly improving dynamic response and reliability. The LTC4268-1 has a unique feedback amplifier that samples a transformer winding voltage during the flyback period and uses that voltage to control output voltage. The internal blocks are similar to many current mode controllers. The differences lie in the feedback amplifier and load compensation circuitry. The logic block also contains circuitry to control the specific and special dynamic requirements of flyback control. The LTC4268-1 high-power power devices, interface controller, and switching regulators have several modes of operation depending on the applied V-port voltage. These various modes satisfy the requirements defined in the IEEE 802.3 AF specifications. The input voltage is applied to the V-port TN pin with reference to the V-port TP pin and is always negative. The power devices must be able to handle power received in either polarity. For this reason, it is common to install diode bridges between the RJ45 connector and the LTC4268-1. For the signature classification and the undervoltage lockout thresholds, the LTC4268-1 extends 2 diode drops below the IEEE 802.3 AF specifications. The LTC4268-1 threshold points support the use of either traditional or Schottky diode bridges. This slide shows a design using the LTC4268-1 in a high-power triple output power device. A high-power sourcing equipment connects through an Ethernet cable to the RJ45 connector. Power sourcing equipment detection and power is passed through the data pair's high-power Ethernet transformer or directly to the spare pairs in the 2-pair 10100 base T-power over Ethernet system. The power sourcing equipment power is then controlled by the LTC4268-1 power devices and forwarded onto the switch regulator. The small supply of the LTC4268-1 utilizes an isolated flyback topology with synchronous rectification that requires no opto-isolator, lowering the parts count. This circuit gives efficiencies at load of 83% when powered from a power sourcing equipment and over 85% power sourced from an auxiliary supply.